You may already be productive with another CAD system. In this short video, we want to show you how to apply your skills with SolidEdge. We'll show you how SolidEdge supports history-based, parametric modeling, configurations, and, of course, synchronous modeling. Our customers tell us that when they combine SolidEdge's history-based and synchronous modeling, their modeling capabilities improve dramatically. Before getting into the user interface, let's talk about data migration. SolidEdge's data migration command translates parts, assemblies, and drawing files from SolidWorks version 2010, Service Pack 5, through the most recent version. So, right off the bat, you can bring your work into SolidEdge. When you start working in SolidEdge, you'll find a clean and simple user interface. If you're familiar with Microsoft Office products, you're already familiar with SolidEdge. Use the Application button to open, save, print, and to see everything you can do with your document. On the Quick Access toolbar, SolidEdge has links to several user interface themes that let you choose the look and feel that works best for you. The Some Assistance theme is similar to SolidWorks. Let's open the model to learn more about the user interface. The ribbon organizes commands into functional groups. Pathfinder organizes a hierarchical view of all of the elements in the active document. In the part environment, it shows the feature tree. In the assembly environment, Pathfinder displays the components making up the assembly. The prompt bar displays messages related to commands as they run. The status bar provides easy access to zoom, fit, pan, rotate, sketch view and view orientation commands. It also contains Command Finder. If you are familiar with other CAD systems, use Command Finder to quickly find the equivalent SolidEdge commands. The Command Finder is a great way to start exploring SolidEdge, and it's the best way to find commands. Families of parts and families of assemblies are similar to SolidWorks configurations. Families of parts and families of assemblies allow individual part and assembly files to control multiple variations of parts and assemblies. The remainder of this video shows history-based and parametric modeling, synchronous modeling, data migration, and families of parts. Keep watching to see how SolidEdge unleashes your modeling potential. In the next couple of minutes we'll walk through SolidEdge history-based modeling. You'll see how SolidEdge supports the skills you've learned with other CAD systems. SolidEdge is a parametric modeling system, so you can parametrically control models by applying formulas to dimensions and PMI. To begin modeling in SolidEdge, create a sketch, or choose a feature command. Regardless of which method you choose, the first step of creating a sketch is selecting the plane where you'll draw. When using a feature command, you can choose an existing sketch, or create a new sketch, as the first step of the command. In history-based modeling, you define your model intent with sketch dimensions and relationships. When you want to edit an existing feature, you edit the sketch that defines it. When the sketch is complete, simply exit the sketch environment. When you work through a command, for example the extrude command, notice the command bar. The command bar guides you through the steps to complete a command, and it is where you can choose options and provide the information required by the command. When you edit a feature, the command bar displays all of the steps to guide your changes. With the extrude command, we picked a plane to sketch on, sketched a shape, and finally extruded the shape to a defined depth. The cutout command removes material in the same manner. To round or chamfer corners, we pick the corner, enter and accept the radius or setback, and then right-click to finish. You can quickly define whole features based on standard sizes and shapes. Solid Edge is smart enough to quickly position the hole where you want to place it. You can pattern and mirror features across a model. SolidWorks has a shell command. We search for this in Command Finder, and it shows us that Solid Edge calls this thin wall, and points to where the command is located. To define the thin wall, enter a wall thickness and click the open face. You can suppress features in Pathfinder. You can also roll back to earlier features in the tree, move them, or insert new ones. You can apply materials, defined in the Solid Edge material table, to parts. When you use the Migration Wizard to migrate existing SolidWorks models, their material definitions are imported as well. Solid Edge supports the same history-based modeling techniques you've used with other CAD systems, like SolidWorks. Check out the assembly portion of this video as well as the synchronous modeling section to see how combining synchronous and ordered modeling opens a whole new world of speed and simplicity. In the next few minutes, we will show you how to get started with synchronous modeling. You'll see how synchronous modeling recognizes your design intent, frees you from the cumbersome mechanism of history-based modeling, and lets you focus on creating designs, not managing your CAD system. Synchronous modeling, just like history-based modeling, starts with a sketch. Solid Edge recognizes any closed regions in your sketch. To form a solid feature, select a region, grab the control handle, and push or pull to define the feature. Once there's a solid body, grab faces on the body and pull them to develop the model. Your design intent is in the model itself, not the sketches that started it. As you modify the model, Solid Edge sees and analyzes every geometric aspect of the design, such as symmetry and coplanar conditions. The Design Intent panel shows these geometric conditions, and it's your tool for controlling the model. Preserve your design intent with the Design Intent panel. As you edit a synchronous model, use it to adjust which geometric conditions Solid Edge maintains and recognizes. Use PMI to drive, or merely reflect, dimensions on the model. Use variables and formulas, within dimensions, to make the model parametric. Design intent relationships can be implied as well as explicit. Define 3D geometric relationships to make your design intent explicit for special cases. Think of these like 2D relationships you might have used in the past. Solution Manager gives live feedback as you work to help you visualize the geometric rules governing your modifications. Use synchronous and ordered techniques together, in the same model, to best express your designs. The greatest benefits of both techniques emerge when you use them together. Whether you're migrating SolidWorks assemblies to Solid Edge, assembling off-the-shelf components, creating families of assemblies, or managing the construction of massive assemblies of hundreds of thousands of parts, you'll find the assembly tools you need in Solid Edge. While you work with Solid Edge assemblies, the library tab lets you browse to locations of model components, and Pathfinder shows the structure of the assembly. Drag components from the library into an assembly to begin assembling, or create new parts in place and model within the context of the assembly. FlashFit uses different geometry types to quickly apply planar align, axial align and mate relationships. A planar align relationship positions components with planar faces aligned in the same direction. Axial align relationships align components along the linear axis, like a shaft and a hole. A mate relationship positions components with faces towards each other. More relationships, such as cam, connect, tangent, and angle, provide a robust set of relationships to define assembly structures. Solid Edge lets you analyze and animate the motion of under-constrained components, including collision detection. You can also define motors to simulate mechanisms. You can calculate physical properties of assemblies, build bills of material, and explode, render and animate assemblies for complete product documentation. If you have used SolidWorks configurations, you will find their counterparts in Solid Edge families of assemblies, which define similar members that vary by well-defined and consistent sets of parameters. Our customers constantly astound us with the size of assemblies they model in Solid Edge, some containing hundreds of thousands of components. Simplified representations of parts and subassemblies, lightweight model representations, and modeling zones help maintain good system performance even when working within massive assemblies. When you migrate SolidWorks assemblies to Solid Edge, key design features such as relationships are preserved, and you can continue developing the models in Solid Edge. We provide help and training to get you started with Solid Edge quickly. The links you see here are just the beginning. Learn to use Solid Edge with searchable help, workflow tutorials, videos, and self-paced courses. Follow the links from the training page to the right Solid Edge learning path for your needs. Find starting points if you are new to CAD, experienced with another system, or just want to expand the skills you already have. Learn about the different tools available in Solid Edge by taking a video tour of the user interface. Search across the entire collection of help and training to find basic concepts, step-by-step procedures, and information on commands and dialog box options. The links on the startup screen are good places to begin learning to use Solid Edge. They will help you become more productive quickly.